Welcome, everyone. My name is Taimur Rashid. I'm the Chief Business Development Officer at Redis. In today's session, I'd like to talk about the machine learning feature store and talk about how it's a cornerstone in modern data architecture for AI and ML. So this session will introduce the feature store. We'll provide some examples of companies actually building and deploying feature stores in production and how they're using a variety of technologies, including Redis. I'd like to take a few minutes and talk about Redis as a company and a technology. I also like to talk about the opportunity and the requirements that are actually fueling a lot of the modern digital applications today. We'll take a look at how architectures have emerged over time to support machine learning and AI use cases. We'll see where Redis fits, we'll share some examples, and then we'll finally close off. So about Redis, Redis is the company behind the most popular open source database, Redis, which is an in-memory data store. We are also providers of a commercial offering called Redis Enterprise, which is a real-time data platform and uses a real-time database as well. What really makes Redis special is how it uses memory to store complex data types, and we can store memory in DRAM, SSDs, or any other kind of memory. It's coded entirely in C, which means it's leveraging the capabilities of the underlying native technology, and it's optimized for performance. It is one of the more popular open source databases out there. It is the most launched on the Docker Hub. We have about 7 million Docker containers which contain Redis that are launched on a daily basis. Sumo Logic has done a survey for 3 straight years in a row and have basically shared that Redis is the most used database in the cloud. And Stack Overflow, which does a developer survey every year, for 5 straight years, Redis has been the most loved database by all the respondents that participate in that survey. The Enterprise Edition powers a lot of mission-critical applications from Visa, their real-time transaction authorization running on Redis Enterprise. Nike uses Redis Enterprise for real-time inventory management. FedEx does a lot of their route optimization, and in being able to have low latency and faster response times and being able to calculate routes, FedEx is leveraging Redis Enterprise. And then eHarmony, in being able to match people in the cloud, they're able to leverage the capabilities of Redis to get quick matches. When we look at Redis as a real-time data platform, it's a unique architecture built for speed. And since it supports a variety of use cases, it tailors to many of the needs of developers and companies. And it eliminates the need for having any specialty databases. When we look at the broad sets of use cases, whether it's for caching, session management, high transaction speeds, or data ingest, or even getting closer and closer to analytics with real-time analytics, recommendation engines, fraud mitigation. And then what's more relevant for our conversation is how Redis is being used for AI and machine learning use cases with the feature store, as well as real-time indexing and search, such as vector similarity search. What really helps this capability and giving this diverse set of use cases that developers can leverage Redis for is the core data structures and the versatile data models that are natively built into Redis. And these are offered in the form of Redis modules, such as JSON, search, AI, graph, streaming data, time series data, as well as Redis Bloom, which is for probabilistic data sets. When you take these versatile data models that can be supported in both the open source database and in Redis Enterprise, and then you combine that with very flexible deployment options, running it entirely in the cloud as a managed service, actually deploying software on-premise and getting the same benefits, or whether it's run in a hybrid mode, the Redis real-time data platform gives a lot of optionality to developers and enterprises in being able to meet all these use case needs for faster results and instant experience. Now let's talk a little about the opportunity in machine learning clearly there's a challenge in deploying machine learning models in production. And a lot of time goes into prepping the data and ensuring that the data that's being used for machine learning is capable of being reused, shared, and highly visible across the organization. And as many companies have gone in and built their own machine learning platforms, there is a core component that's emerged in the data infrastructure, and that is the feature store. And increasingly over the past 18, 24 months, we've seen data science teams, whether they're data science or data engineering teams, turning more towards the feature store to manage these data sets, manage the pipelines that are needed to eventually get machine learning models into production. Redis actually did a joint study with Forrester Consulting recently, and a few key takeaways came from that, where the respondents responded, basically indicating that there is a need to modernize the data infrastructure that powers AI and machine learning. About 40% of decision makers believe their current architectures won't be able to support their future needs. 64% cited that around 20 to 39% of their models are actually built on real-time data streams or connected devices. So this emphasis on real-time is really increasing. Performance and reliability continue to be top challenges. And about 49 respondents actually said that they can improve data preparation efficiency just by ensuring that various components of their underlying infrastructure are modernized. Now, as we look at modern digital application imperatives, we really see that businesses are demanding real-time. And among them, there's 6 characteristics. There's speed, scalability, the ability to be always on, global distribution, security, and as much AI as you can infuse in these applications. More specifically, what's very important is speed, response times. And this is where Redis brings a lot of applicability to the machine learning use case. Now, why real time? Well, businesses are constantly evolving. Companies need to adapt and change quickly. The acceleration of digital businesses is resulting in more data being captured across so many different channels of the customer experience. And so the business characteristics, whether it's time sensitivity, whether it's customer facing impact, quick responsiveness to constantly changing regulations, or adherence to business SLAs, these business characteristics are really driving technical requirements. And those technical requirements are low latency access to data processing, the ability to scale to lots of requests and processing, being able to version data and models, access control, and being API driven. And in fact, the more API driven companies can be, the more agility they can get to innovate much faster. Now, when we look at machine learning, there's certain use cases that truly require real-time response, sub-millisecond latencies, due to the high degree of real-time changes that happen in the external environment. And real-time ensures adaptability and business resilience. You can build models based on known inputs. And so when you take sales forecasting, image classification, predictive analytics, or even pricing optimization, you can generally build those models based on known inputs for the most part. Now, there's a variety of use cases where, as much as you can build on known inputs, you are going to come across unknown inputs as well too, which happen in real time. Fraud detection's a great example. Cybersecurity, product recommendations, and new consumer usage patterns. All these new things get experienced in real time, and the quicker organizations can actually take that real-time data and help refine and build their models, the quicker they can respond to driving, outcome-based results. So how have AI and ML architectures evolved? Circa 2017, we've largely seen companies take a monolithic approach to how they build these architectures, and a very monolithic domain-specific service. So you'd have, fraud detection team, a recommendation engine team, maybe even a team that's doing sales forecasting. And effectively, you would have functional tasks being encapsulated in each domain team, which resulted in high-touch cooperation between data scientists and software engineers, but also resulted in certain inefficiencies that got created. As you had all these different domain teams creating their own functional tasks, there was a lot of duplication going on. At the same time, a lot of inefficiencies with models and data that were being created across all these teams. Now, over time, as companies have evolved their architectures, the modern data architecture is more about being modularized by functional tasks. It is separating model deployment versus feature deployment, bringing more streamlined flow between data scientists and software engineers for better efficiency. So you can take very domain-specific code and basically, modularize it from the infrastructure, and then take your infrastructure tasks that are most common and modularize them, thereby giving a lot more efficiency to the teams. What really has happened, though, is the feature engineering platform being emerged. And the modern feature platform basically provides centralized stores and standardized communication between engineering teams, so you can actually move and transform data in a much more streamlined way. And what's really happened is now you have these modularized components like governance, storage, transformations, all being accessible via API layers, and then factoring in deployment at scale for machine learning teams. What we really like to focus on for this conversation is the store piece, right? And so how do you actually store and serve machine learning data? This is where, when we take Redis's first principles on low latency, high throughput, and speed, Redis plays a key role in core operational ML data stores in the production stage. And so when you take the feature engineering process, whether using open source technology, third party, or even the cloud platforms, the first manifestation of Redis in production is as an online feature store. Low latency data store, which stores features and can serve them to model inferencing components for online predictions. Secondly, Redis Enterprise actually has a capability of storing Redis on flash, so data on flash, thereby giving developers and customers the ability to store larger data sets in Redis. And the offline manifestation of Redis as an offline feature store can be used for model training. Interestingly enough, Redis can also be used as a model store to store pre-trained model binaries for faster response times. And as you deploy them to model inferencing or even batch applications, the fast nature of Redis actually can store the models, which is another way of saying a model cache, giving faster response times. Now, with all three manifestations of data stores for machine learning, storing data about feature data, about model performance, one can actually tie in model monitoring to the applications and then store this data in an evaluation store, which can be further analyzed for either live updates to the online store or introduction of retraining. And this is where the evaluation store can be used. So as we take these four aspects of how Redis can be manifested, it's very interesting to see how companies have taken this technology and actually built feature stores for a variety of use cases, from personalization, recommendation systems, fraud prevention, and many more use cases. Here are some companies that have taken Redis in the different forms that it's available and being able to actually leverage it as a feature store. From Doordash, supporting multiple use cases, AT&T using the feature store for fraud detection, Zomato for personalization, and several other customers here that are using it for product recommendations, entity matching, and fraud detection. What I'd like to do is really dig deep into the Doordash use case. Doordash uses machine learning to power a variety of use cases, from how they do assignment optimizations, how they balance supply and demand, fraud prediction, search ranking, menu classification, and recommendations. They've taken a modularized approach for how they've actually built their underlying infrastructure to support machine learning. And two key things that they've done is the feature store, which is a low latency store for which their prediction service actually takes common features that are needed for the model to do an online prediction. Secondly, they actually store, they also use a model store, which actually stores the model files and metadata, and constantly using that to identify which models are active, which need to be changed. It gives them a whole way of doing model management. What's very exciting about Doordash's use cases, again, how they've modularized the different components here and how they've leveraged Redis to get the fast, low latency feature serving for their prediction services. The second example is AT&T in how they've actually centralized the feature store to speed up AI development. And AT&T have actually deployed a centralized machine learning feature store so that a data scientist can actually reuse and revise features quickly to build and deploy AI models. They built this feature store, and what's very interesting about it is how they've actually leveraged a variety of technologies to serve multiple needs. So for model deployment, where they can actually do model lineage and versioning, do some A/B testing, and manage the overall model lifecycle management, they use MLflow for MLOps. For their offline training, where they need higher throughput and scalability, they need features like feature versioning, time travel. They leverage Delta Lake. Now, for model online scoring, where they need very, very fast speed, they need high scalability, they need consistency across features, and they need high availability, they're using Redis. And then finally, for data governance or feature governance, how they do metadata management, discoverability, access control, and ensuring that they meet with compliance and legal, they are using MongoDB and Hive. And so what you actually see here is enabling a feature store at scale, for globally distributed teams. It's a best of breed solution with a variety of technologies there, all serving specific purposes across the entire ML lifecycle, from model deployment, offline training, online scoring, and feature governance. So finally, what I like to do is end by saying, with Redis, customers have been able to rediscover how it can be used to power machine learning use cases. And the very nature of Redis, in its ability to be low latency, high throughput, and fast and simple, it can ensure that your feature store is live, fresh, and fast, that your features are live, fresh, and fast. So our message, and we're working with a number of customers today to build their feature store, model store, evaluation store on Redis. This really gives a foundational layer for real-time serving, the opportunity to build continuous retraining, so you can have augmented vector predictions at very, very, very low latency. You can read more about this ability of Redis by going to redis.com. Thank you so much for the time. Hope you found this helpful, and enjoy the rest of the conference. Thank you so much. Bye-bye.